Today what we're going to spend some time going over is verifying some trig identities. Very similar to what we've done in the last class periods. But now we have sort of an end result, a goal in mind, and we have to take what's on one side and make it exactly match what's on the other side. We will use our algebra to do that. We'll use our trig identities to do that. We replace things. We are not allowed to do things like squaring both sides in this problem. It doesn't work that way. We don't know if this problem is actually equal. That's what we're trying to verify. So we're only allowed to do work on one side of the problem. Now, another thing that will help you as we go along, some of you will discover that if I do work on this side over here, and maybe think about it for a little bit, and then perform some work on this side over here separate from each other, but try to bring them down and maybe both sides work their way down a little bit, and then down here somewhere they match, that's okay. But you're only allowed to consider things on one side. So the algebra of adding something to both sides of the equation, or dividing something from both sides of the equation, multiplying something to both sides of the equation, doesn't quite work. So we have to make replacements. Another suggestion for you to work on these problems is to look at both a start spot on the left, and generally we're going to start on the left side. Every once in a while the right side will be a better one to start with, but generally it's the left. And then consider things on the right and think about what has to be done to get to that end point. So if I look at that numerator, oh, by the way, you do remember your algebra from roots that says this can be split up as the square root of 1 minus the cosine of x over the square root of 1 plus the cosine of x?
Yeah.
I hope you really remember that. If you look at this, the numerator part essentially has been squared, or taken times itself to have 1 minus the cosine of x arrive outside the square root. Would you agree with that?
Yes.
Everybody understand that idea? So that's going to be a hint, suggestion, idea as a first step. I'm just going to take the top and the bottom of the fraction and multiply by the square root of 1 minus the cosine of x. Or multiply it to itself. So if I take the square root of something times itself, what is my result to that? A quantity that says there's a square root times itself, what happens to the square root parts? So I'm left with 1 minus the cosine of x. Now in the denominator, I've got 1 plus the cosine of x and 1 minus the cosine of x both under that root. So multiply it out. See what you get when you do that. What do we get?
Square root of 1 minus the cosine squared of x.
Yep. Now I'm hoping that that square root of 1 minus the cosine squared of x is beginning to look familiar to you. Have we seen that structure before?
Mm-hmm.
What is that structure equal to? So 1 minus the cosine of x in the numerator over the square root of sine squared of x. And the square root of the sine squared of x happens to be? No. Absolute value. Why is it that I have to include absolute value down here on the denominator, and I do not have to include it in the numerator on this problem?
Because it's an even root.
Well, they were both even roots.
The other one was canceled cleanly.
Well, it had nothing to do with whether or not it cancels cleanly. So I had 1 minus the cosine of x, the quantity squared up here, and I took its square root, and I just said it's 1 minus the cosine of x. I didn't put absolute value on it. Down here, I've got the square root of the sine squared of x. Same concept, same idea, except for now I put absolute value on it. What's different? Because I'm not changing the rule. Nope.
It's a single term by itself, whereas the other one's two.
Closer, but still not quite. Okay, think for a minute. What is the absolute largest value the cosine of x can have? The cosine at 0 radians is 1. The cosine at 2 pi radians is 1. And it repeats a pattern where it's 1 every 2 pi after that. What's the absolute smallest the cosine can be? Negative 1, and that occurs at pi radians. This value is stuck between plus and minus 1. Never gets less or bigger than that. And if I have 1 take away its biggest quantity of 1, the smallest that's going to be is 0.
So that one has to be absolute value because it carries 0 and with the 1.
Nope. We have to make a note that the sign could not be at 0 or at pi or at 2 pi because that makes it 0 down there. What we have to understand is the sign also oscillates between negative 1 and positive 1. And when something is squared in here and it's a negative times a negative is understood or implied to be positive after that, outside the square part before we root it. So the root is a positive root. To maintain a positive out of this thing, I have to put absolute values on that because it can be negative in places. Even though the cosine can be negative, it never adds out to be a negative out of the root. That's why it doesn't need an absolute value on the top. You should remember that from algebra 2. You're supposed to remember that from algebra 2.